Let's see if we can't use this method for the next two problems. So part B. Part B was 3 to the 2x minus 1 plus 5 equals 0. So applying our solution method here, we're going to get this exponential on its own on one side by subtracting 5, and we get that 3 to the 2x minus 1 equals negative 5. Now we could try to continue at this point, but if you look at this for long enough, you'll realize that we're trying to solve an equation for which a number to a power is negative. One of the properties of exponential functions, if you do some base to a power, then this is always positive. We actually wrote this statement in a bit of a different way. The way that we wrote it is that the range of a to the x is all the positive numbers, so 0, infinity. Essentially, you can never do a to a power and get a negative. And so the first thing to do is to rewrite in form 1 or 2. If it's possible. If it's not possible, you can't use this method. Or at least you can't use this method as I'm going to describe it. So that's what you need to do first. The next thing you need to do is you need to take logs. Take the log of both sides. And use those log properties that we've talked about. Log properties. And if we revisit our solution, we can see that's what we did. We started again with 2e to the 3x minus 17 equals 0. And we rewrote it so we get this star here. Then we applied logarithms to both sides, and we used the properties of the logarithms to get to this step. And what resulted right here was a linear equation. X times a number equals another number. So the final step, since you cannot raise 3 to any power to get a negative, then the answer here would be no real solutions. Now, suppose that you were doing a lot of problems and you did not notice right away that there was a negative. You'll catch this soon after by doing the following. So you'll be following the solution method. You'll say, okay, now I'm going to take the logarithm of both sides. Let's say ln of 3 to the 2x minus 1. Remember, you can choose whichever logarithm you'd like. Typically, I will say the natural logarithm is the default choice, but I digress. We take the logarithm of both sides, we use the logarithm properties, and we get 2x minus 1. It is important to have this parentheses here, times ln of 3 equals ln of minus 5. And if you didn't catch that there's no real solutions at the previous step that I marked star here, then you will likely catch it here because you'll see ln of a negative number, and you cannot do the natural logarithm of a negative number. So again, at this step, you would say natural logarithm of a negative number, you would say no real solutions. Now, in the interest of getting some more examples done, let's go ahead and imagine a slightly different problem where this was instead subtraction instead of addition. So let's say it read 3 to the 2x minus 1 minus 5 is equal to 0. Then we would perform similar steps. Instead of subtracting 5, we'd add 5 to both sides. So we get 3 to the 2x minus 1 equals 5. We would take logarithms, and I think this time I'll just take the common logarithm. So log of 3 to the 2x minus 1 equals log of 5. And now this 2x minus 1 can drop down. Make sure you put parentheses on this. And you have to put parentheses because you have the addition of two things here. So 2x minus 1 times log 3 equals log 5. And we need to solve this for x, which you can do in a couple different ways. I think in this problem I'll first divide by log 3 on both sides, so that gets me to 2x minus 1 equals log 5 over log 3. Then we can add 1 to both sides, and we would get 2x is log 5 divided by log 3 plus 1. And then I'll divide by 2, or in other words, multiply both sides by 1/2. That's the exact same thing. So we get x is 1/2 log 5 over log 3 plus 1.